if instantaneous current is equal 50 milliamps at angle theta 45 degrees and time equals 2 milliseconds, determine the mathematical expression for the sinusoidal current. First, we're supposed to write everything what is given. We have instantaneous current, which is equal 50 milliamps. We have theta, which is equal 45 degrees. And we have time, which is equal 2 milliseconds. We have to find the mathematical expression for this current. So what we're supposed to do first? We're supposed to find I peak. Remember the formula for the sine wave, which says instantaneous current is equal I peak times sine theta. What we have given? We have instantaneous current given and we have angle given. We can calculate I peak from this formula. How I can do so? Simply divide both sides equation by sine theta. Sine theta. Sine theta and sine theta will cancel out, and I'm going to have peak current is equal instantaneous current divided by sine theta. Simply plug in the values. I is equal 50 milliamps over sine of 45 degrees. Use the calculator and make sure that the calculator is going to be switched to degrees, because this time we have degrees, angle expressed in degrees. This is going to be equal 70.71 milliamps. This is my current peak. Next, we're supposed to find omega. Please notice that omega t is nothing else, just the angle. Because next to sine, we have always angle. So this part is nothing else, just what? Theta. But omega t is expressed in radians per second. My angle is expressed in degrees. So what I have to do first, I have to convert my degrees to radians. Remember, formula for radians says radians are equal pi over 180 degrees times degrees. This is equal pi over 180 degrees times 45 degrees. 180 is divisible by 45, and 45 degrees is also divisible by 45 degrees. So I'm going to have pi over 180 divided by 45 is 4. 45 divided by 45 is 1. So I can say my answer is pi over 4 radians. This is my angle expressed in radians. Next, remember we said that omega t is equal theta. We are looking for omega because this mathematical expression, the formula for sine wave, has omega. In order to find omega, I have to divide both sides of the equation by t. T and t will cancel out. And I have omega is equal theta pi over 4 radians, pi over 4 radians, divide by t. And t is 2 milliseconds. That's why I'm going to have 2 milliseconds. But because I'm dealing with fraction over here, I'm going to convert 2 milliseconds to fraction by writing over 1. This is equal pi over 4. Remember, division we have to change to the multiplication. And we have 1 over 2 milliseconds. This is going to be equal pi over 8 milliseconds. Pi divided by 8 milliseconds is going to give me 125 pi radians per second. So this is my omega. Next, I'm supposed to simply plug in these values into my mathematical expression. This is going to be equal I 70.71 milliamps. This is my peak current, and I'm going to write milliamps over here in order to do not forget later on. Sine my omega is equal 125 pi, and I simply copy t. This is the solution to my problem. If you want to verify your answer, you're supposed to, instead of t, write 2 milliseconds and enter these numbers one more time into the calculator. Simply type 70.71 milli times sine and open parenthesis 125 pi times t, 2 milliseconds, close parenthesis, and press equal. You're supposed to get 50 milliamps. If you get 50 milliamps, means you did all operations correct. So this is the solution to my problem.